Hello everybody, this is another video lesson from the Mathy project, and today we will speak about the integration of rational functions. Moreover, we want to obtain the definite integral of a rational function. To do this, we need to know very well how to integrate a rational function. A rational function is a division of two polynomials. Let's call capital P to the polynomial under the numerator and capital Q to the polynomial under the denominator. So let's consider also that m is the power of capital P and n is the power of capital Q. The idea now is to compare both powers. So, in this case, we have two situations. The situation where the power of capital P is greater or equal than the power of capital Q, and the opposite, the power of P is less than the power of capital Q. The first case is about when the power of capital P is greater or equal than the power of capital Q, meaning that we have m greater or equal than n. In this case, we need to perform a long division. After we performing a long division, we need to rewrite the initial division, and in a lot of cases we need to apply the second case to obtain the final solution. Just a small remark: to rewrite the division capital P by capital Q, and after performing the long division, you need to rewrite this division in this form, meaning that the capital P over capital Q will be equal to small q plus r of x over q of x, being the small q the quotient of the division and the capital R being the remainder of the division. Consider now the second case. In this second case, we have m smaller than n, meaning that the power of the capital P polynomial is smaller than the power of capital Q polynomial. So, in this case, the partial fractions must be used. And what do we need to do? In the first step, we need to obtain the factors of the Q polynomial, meaning that, of course, we need to factorize the capital Q polynomial if possible. Then the next step, the step 2, we need to rewrite P over Q, taking into account the partial fractions related with the factors that we obtained previously. To visualize this, we will show you some examples of the partial fractions related with the factors that we obtained using the decomposition. For instance, if the polynomial capital Q is given by x plus 1 multiplied by x plus 2. Note that both factors are linear. Then, in this case, the partial fraction related with x plus 1 is a constant by x plus 1, and the partial fraction related with x plus 2 is another constant by x plus 2. The next case appears when we have a factor with a different power from 1 and another factor with power 1. In this case, since we have a power 2 in the first factor, we have two partial fractions, a2 over x plus 1 square plus a1 over x plus 1, and the last factor only has one partial fraction, b1 over x plus 2. The final case that we will present is when we have a linear factor and a quadratic factor with no real solutions. So the linear factor is related with the partial fraction a1 over x plus 2, and the quadratic factor is related with the partial fraction constant plus d times x over the factor, in this case, x squared plus 1.